Chapter 4 in Math 039 is about simplifying expressions and solving equations. And the first section is on the commutative, associative, and distributive laws. The commutative law is a law that suggests that order does not matter. So for example, A plus B is the same as B plus A, and A times B is the same as B times A. Again, these laws mean that order doesn't matter in multiplication or addition problems. So we want to use the commutative law to rewrite the expression in another form. If you have 5 plus x, that's going to be the same as x plus 5. And if you have x times 2, that's the same thing as 2 times x. We can write 2 times x with the multiplication dot in between, or just as 2x. Next definition. A term is a constant, a variable, or a product of constants and variables raised to 2 powers. For example, a number just like 2 is a constant, is a term. A variable like x is a term. A product of a constant and a variable, something like 8x, would be a term. And those variables can have powers, so something like negative 4y squared would also be considered a term. Terms do not have addition and subtraction in them. Addition and subtraction are symbols that will separate two terms from each other. Okay, so when an expression contains both constant and variable terms, the variable terms are usually written to the left of the constant terms. So the expression 7 minus 3x can be rewritten. So the variable is to the left. Notice that the 3x is negative, the 7 is going to be positive. So if we're going to put the 7 at the end, we're going to have to say plus 7 to write that at the end. This would be in the normal order, the order that terms are usually written, variables decreasing left to right. Next, we have a new law. The Associative Law is a law that says if you have just additions or just subtractions, you can do them in any order. So for example, A plus B plus C could be done as A plus B plus C. So what we're saying here is that you can either add the first two, A and B, then add C, or add the last two, B and C, and then add A. You can do the same thing if you have just multiplications. If you need to multiply A times B times C, you can multiply A and B first, then multiply by C, or you can multiply B and C first, and then multiply by A. So either order is going to work right there. And what this is really saying is that grouping doesn't matter if you're looking at just addition and multiplication problems. It does matter if you mix multiplication and addition. It does matter if there's division or subtraction, but if your problem only has addition or only has multiplication, the grouping in that problem doesn't matter. So let's use the associative law to rewrite the following expressions. The associative law is going to say I can regroup this to W plus the sum of 4 and 6. And I know what the sum of 4 and 6 is, so that's going to allow me to write this as W plus 10. In the multiplicative case, the associative law is going to allow me to regroup this to multiply 8 times 4, then times x. That's what allows us to multiply 8 times 4 to be 32x. So it's the associative law that's allowing us to simplify these expressions. In example 4, I'm going to rearrange the terms so that the numbers can be added. The commutative law is going to allow us to rearrange terms. So let's rearrange the first two terms. 7 minus 5x could be written as negative 5x plus 7. And then the associative law is going to allow us to group these last three numbers and add them all up together. So we're going to end up with negative 5x. 7 plus 3 is 10, minus 9 is 1, so plus 1. The next law is the distributive law, and the distributive law states that if you have a product across a sum, you can multiply the product into both parts of the sum. So A times the quantity B plus C is A times B plus A times C. This law means that we can remove parentheses if we multiply the outside term by each term on the inside. All right, we're going to use the distributive law in the next example. If I have 2 times the quantity x plus 3, I'm going to multiply 2 times x and 2 times 3. Simplifying, we know what 2 times 3 is, so this will be 2x plus 6. Same thing in the next one. If I'm going to multiply 4 times the quantity 2x minus 8, I'll start with 4 times 2x is 8x, minus 4 times 8 is 32. Example 6 is going to have us using the distributive law a few more times. The distributive law will apply to 6 times 5t minus 3. 6 times 5 is 30t, minus 6 times 3 is 18. The distributive law works both on the left and on the right. If the number that I need to multiply by is on the right of the parentheses, I will still distribute it into both parts of the inside. 2 times x is 2x, and 2 times negative 9 is negative 18. If I multiply the negative 4 into this parenthesis, negative 4 times 7 is negative 28, and negative 4 times negative x, two negatives make that a positive 4x. My last step here is to use the commutative property to rewrite these in the order that's going to have the x first. So we'll write it as 4x minus 28. I can also do the distributive property if I have 3 terms in the inside of a quantity. So negative 3 times 2p is negative 6p. Negative 3 times negative 4t is positive 12t. And negative 3 times positive 6 is negative 18. That's it for this section.